Welcome. In front of you, you should see a graph of y equals f of x in purple, and then in blue, a graph of y equals f prime of x. We're going to use these graphs to discuss what it means for the first derivative, that is this graph. What does it mean to be positive, or when it is positive? What about when it's negative or zero? And then when it's increasing and decreasing, what that means and tells us for the second derivative. If you're following along in my Canvas course, you'll notice that down here you have an axis with no graph. We're going to use that to sketch a graph of the second derivative of this function f of x. So let's begin by discussing what it means for y equals f of x to have a positive slope. I hinted at that here by saying, what does it mean for f prime to be positive? Well, when this function f prime is positive, that is when it lies above the x-axis, that tells us that this line y equals f of x has a positive slope. So let's review the roller coaster analogy again. If this purple line here is a roller coaster, then your car that you ride in on the roller coaster represents the slope, represents the tangent line at any point. So the slope that your roller coaster car has will match the slope of the function at any point. And as you can see, the slope is positive throughout except maybe at one point. And I'll label that point. And I'll label that point A. This A corresponds here to where f prime of x intersects the x-axis. But before we get to that, let's stress that this positive slope on the graph of f of x corresponds to the graph of f prime of x lying above the x-axis. So it's completely above the x-axis. And here in green, I've just reiterated what I've already said. When the line of the tangent to f has a positive slope, I know that the first derivative f prime is positive, so the graph of f prime lies above the x-axis. From both of these pictures, in fact, I can tell that starting over here around negative infinity, so we're coming in from the left, all the way to A, we can tell that on negative infinity to A, f prime of x is greater than 0. And I purposely left this gap here because if we were rating this as a roller coaster, we're going uphill. We briefly flatten out, but then we're going uphill again. That tells me that from A out to infinity, the first derivative, that is f prime of x, is also greater than 0. So on this interval and this interval, our first derivative is greater than 0. That is, the graph of y equals f prime of x lies above the x-axis on both of these intervals. Next, let's discuss what it means for the graph of y equals f of x to have a slope of 0. That occurs right here at x equals a. If I were to sketch out this entire tangent line, that tangent line is flat and parallel to the ground. So the slope of that tangent line is 0. Looking down below, that spot corresponds to the x-intercept of f prime of x. So since at x equals a, this function is flat, the graph of the first derivative must intersect the x-axis here, since the graph of the first derivative represents the slope of the function at that point. At a, the slope of this function is 0, so that means the graph of f prime of x is 0, i.e. it has an x-intercept. So here in green, I just wrote a sentence that reiterates the point that was just made. At x equals a, f is flat. So that means f has a slope of 0. This means that the first derivative, f prime evaluated at a, has to equal 0. So at x equals a, the graph of f prime of x must have an x-intercept, which visually we see here. Finally, what does it mean if the graph of f of x has a negative slope? Well, again, building on this roller coaster analogy, if we're riding this roller coaster, we actually on this stretch have only gone uphill. So there has been no stretch where we're going downhill screaming with our arms up as we go down the roller coaster. So on this stretch, we can verify it by looking at the graph of the first derivative. The graph of the first derivative remains above the x-axis the entire time. It never dips below the x-axis. So that confirms our suspicion that the slope of this function is positive on this interval, except here, of course, at a. So down below, I've written two sentences that correspond to what we just discussed. That is, f of x does not have a negative slope, so f prime of x lies above the x-axis, because a negative slope for the function y equals f of x corresponds to the graph of y equals f prime of x lying below the x-axis. Okay, so now let's discuss what does it mean when this first derivative is decreasing, or increasing, or 0, and use that to sketch a graph of our second derivative. So now, if this blue curve is the roller coaster we're riding, this is the frame of the roller coaster car along the blue curve represents the slope of the first derivative. So the slope of y equals f prime of x, that is the slope of the first derivative, is negative from negative infinity to a, because as you can see, I'm repeatedly drawing these small little tangent lines, that is these small little roller coaster cars along that curve, and they're all going downhill. So we can mark this spot x equals a. So if now we imagine this blue curve is our roller coaster frame, when we're riding after x equals a, the roller coaster is going uphill. That tells me that the slope of the first derivative is positive to the right of x equals a. So when I sketch y equals the second derivative of f, everything to the right of a should lie above the x-axis. So to reiterate, here in green I wrote, when the line tangent to the first derivative has a positive slope, then we know the second derivative, that is its graph, has to lie above the x-axis, and you can see that here. Now what does it mean for the first derivative, that is y equals f prime of x, to have a slope of 0? Well, that's here, so that's a flat spot. This tangent line is horizontal, so its slope has to be 0. That tells me that the graph of the second derivative has to intersect the x-axis there at a. And to reiterate, at x equals a, y equals f prime of x, so the first derivative is flat, as we can see here. So the second derivative evaluated at a has to equal 0. That is, this y equals f double prime, so the second derivative graph must have an x-intercept at x equals a. Have you caught on to the similarities between these interpretations yet? When the slope of our function is positive, we know that the first derivative lies above the x-axis. Similarly, when the slope of our first derivative is positive, we know that the graph of the second derivative must lie above the x-axis. When the graph of f of x is flat, that is, has a slope of 0, we know that our first derivative, that is the graph of f prime, has to intersect the x-axis. When the first derivative is flat, that is, when this has a slope of 0, we know that the graph of this second derivative also has to intersect the x-axis. So what do you think it means for the first derivative to have a negative slope, that is, on this side? So please, again, pause your video and answer this question. What does it mean for y equals f prime of x to have a negative slope? Okay, so now that you've paused your video, you should have written a sentence that is really similar to this one here. That is, when we answered the question, what does it mean for y equals f of x to have a negative slope? A negative slope for y equals f of x corresponds to y equals f prime of x lying below the x-axis. Similarly, what does it mean for y equals f prime of x to have a negative slope? Well, when f prime has a negative slope, the graph of the second derivative, that is y equals f double prime of x, lies below the x-axis, and you can see that here. I hope this video was helpful.